So we are going to start with defining some of the common terms in the laboratory. First, let's look at hazards and what they are. Hazards are any source of potential damage, harm, or adverse health effects on something or someone. All chemical that surrounds us in our daily life are hazardous. That is why proper handling, storage, and disposal is important to reduce any chemical-related accidents. Knowing what hazardous is, what does that mean for us? Like, what are the implications we need to be aware of? This is where we need to define risks and what they could mean to us in the laboratory. So risks are the chance, or risk is the chance or probability that a person will be harmed or experience any adverse health effect if exposed to a hazard. Situations with property or equipment loss or harmful effects on the environment are also included as risks. So now that we know this definition, we should be able to start looking at what we can do about these hazards. So does anyone know what should be done? Like, anyone has any idea what should be done about these hazards? Okay, I would say that risk assessment has to be conducted. So there's three phases on this risk assessment. There's hazardous identification, risk analysis, and risk evaluation, then risk control. So the process goes like: the hazardous and risk factors that have potential to accuse or to cause harms are identified. That's the hazardous identifications. Then risk associated with the particular hazards are analyzed and evaluated. That's the process of risk analysis and risk evaluation. And then appropriate ways to eliminate the hazard or control the risk are determined. There's the risk control. So then the risk assessment is completed. Now let's have a look at some of the common hazards we come across in the lab. I know when many people think of hazards in the lab, what comes to mind first is biological agents. These would be the pathogenic organisms we deal with, such as Ebola and other viruses. Then we also should think about the carriers of some of these pathogens, like animals. As the scientists and lab operators, they conduct some experiment in some of these animals. They also can pose risks to the operator by biting them, or go wild and bite the operator and transmit the virus to them. Then we have the chemicals. So the chemicals we use, they can be toxic, carcinogenic, or corrosive. Even people can be a hazard in a laboratory. An unprepared and unauthorized person can be quite dangerous if they don't know the correct process to follow. And then we have the equipment. We should always include the equipment in this mix, such as needle stick injuries in hospital settings, for example. Even electrical hazards should be considered, like overloaded plugs, exposed wire are all things that should be taken into account. Okay, now that we have mentioned some chemicals as some of the chemicals that pose risks or that are hazardous to in the lab. So all of these are quite common in a lab setting and should only be handled by experienced and trained individuals. All of these chemicals are listed here. So knowing that the chemicals we use are hazardous, what are some examples of the potential risks of using them? For example, we have formalin, present risk of an operator having asthma and or leukemia if exposed to it so many times. We have benzene, can cause anemia, irregular menstrual period, and affects fertility. Then hydraulic acid, lung damage, pulmonary edema, death or death. Sulfuric acid may cause burns, difficulty in breathing, and pulmonary edema. Why are these chemicals so hazardous? What risk could they pose towards an individual? Here we have a short illustration on how they could affect a person. It could affect the nervous system, the eyes, chest and lungs, skin, and reproductive system. So now that we know some of these, some of the dangers of these chemicals, how do we go about using them safely? We look at classifying them into their respective hazard or their respective hazards to work with them safely. So classification of chemicals is a scientific assessment of whether it can cause harm. For example, whether it has the potential to cause cancer, explode, irritate the eyes, and etc. So chemicals are classified so that people using them either in industry or as consumers can understand any hazardous effect they could have on human health or the environment, and to protect against that harm. The Occupational Safety and Health Regulation, or CPL 1997, is a Malaysian regulation aiming to controlling the supply of hazardous chemicals in the workplace. To ensure sufficient hazard information is provided by suppliers to aid in mitigating the risks these chemicals pose. A reason why we have these labelings on the chemicals containers. Here again, we have an overview of some of these warning labels commonly seen in the lab. The main objective of the class regulation is to ensure chemical suppliers provide sufficient information on hazards of chemicals so as to mitigate the risks of incidents happening in the workplace. For example, we have the GHS01, which represent the chemicals in explosive chemicals, or chemicals with explosive reaction, chemicals in that family. So they are a stable explosive self-reactive substance and mixture. This signifies a substance or mixture that is explosive or has a fire blast or projection hazard. It indicates that the material can explode due to heat, friction, or other factors. For example, we have precolic acid, and the labeling or the sign would be exploding bomb. To check on the container, this sign is for the explosive chemicals. Then we have the flammable family of chemical, which the code should be GHSO2. It refers to gases, aerosol, liquid, solid, organic, peroxide, or organic peroxide, and materials that ignite easily. And for example, we have the methanol, xylene, hexane, 2-propanol, and ethanol. For example, methanol can be used as a fixative for blood smear staining. Another example is the 70% isopropyl alcohol used to sterilize surfaces. So the labeling or the sign that you would be in such chemicals on this the flammable family would be a flame on the container. Then we have the oxidizing family, which the code is GHSO3, a material that spontaneously evolve oxygen or at room temperature or with slight heating or promote combustion. Example, we have peroxides and chlorates. Organic and inorganic peroxide could be commonly found in research labs, for example, as polymerization initiator. So the labeling of this chemical family would be flame over a cycle, like you see on this slide. Then we have the compressed gas family, GHSO4. Contained gas under pressure, may explode if heated, contains refrigerated gas and may cause cryogenic burns or injury. For example, we have liquid nitrogen. So this alerts us or alerts the users in the lab to potential danger like explosion if heated or cryogenic burn from refrigerated gases, as you see on this slide. So the sign be a gas cylinder, as you see on this illustration. And then we have the corrosive family, GHSO5, destroys and damages other substance with which it comes into contact with, or it causes chemical burns. For example, we have sulfuric acid, and the labeling sign would be corrosion, as you see, like drops on the object and on the hand burning. The drops are burning both hand and the object. Hydraulic acid, for example, is commonly used in your pathology labs as a preservative in urine tests, and is one of is part of the corrosive family as well. Then we have the toxic family, which are fatal if swallowed, and fatal in contact with skin, fatal if inhaled, toxic if swallowed, toxic in contact with skin, and toxic if inhaled. So example, we have mercury, methanol, and pesticides. And the symbol for the toxic family chemicals would be a skull and crossbones, like you see in this illustration. Again, not only is methanol flammable, but toxic as well. So various chemicals can have multiple classification. You should be aware of this. Then we have the harmful family, which may cause respiratory irritation, may cause drowsiness or dizziness, may cause all allergic skin reaction, causes serious eye irritation, causes skin irritation, harmful if swallowed, harmful in contact with skin, and harmful if inhaled. And we have, as example, the Hennexine, xylene, tetrahydroforin. So the labeling for these chemicals is the exclamation point. In very severe case, xylene, for example, can lead to coma and even death if exposed to high enough concentration and long enough period. So these chemicals really pose high risk to the human health. Then we have the health hazard. May be fatal if swallowed and enters airways, causes damage to organs, may damage fertility or the unborn child, suspected of damaging fertility or the unborn child, may cause cancer, may cause genetic defect. Example, again, we have the Hennexine, the xylene, and and tetrahydrofuran. So the symbol for this chemical family is a star, a person with a white star in the middle, the health hazard chemicals. So these chemicals, they are in two families, the harmful and the health hazard. Then we have the GHSO9 environment. So these are chemicals that can cause also harm to the environment. We're saying like water or soil. So they are toxic to aquatic life with long-lasting effect. So acute and chronic hazards to the aquatic environment. For example, we have turpentine, petroleum, and diesel. And the symbol would be basically the environment, as you see, fish, trees, and soil. Yeah. Not only are we exposing ourselves to this risk, but the environment as well. Aquatic life, even soil, can be affected. A good example would be the CFCs that were linked to ozone depletion. Mostly we're referring to refrigerants, and the introduction of safer HFCs, which are friendly to the environment. If you see some of the ESCO units or the refrigerators and freezers, they use the HFCs, which cause no harm to the ozone. So this is a summary of all of these chemical families we just went through.